Okay, welcome back to the second part of the video. Hopefully you've taken a few minutes to attempt example 3 and also our slope question over here, and I'll just go very quickly over the answers. So if we look over here at our car example, we're looking to find x. So we wish to find the angle of a hill in the example at the right if we know that the gradient of the road is 8%. And so what we can do is look at 8%. We know that 8% is 8 over 100. And so what that's saying is we have 8 units of rise for every 100 units of run. And so we can set up a tangent ratio. The slope is rise over run. So tangent of angle x, which is slope, is equal to rise over run. And we can then solve for x, find the angle that the heel makes with the ground by reversing the operation. X is equal to arctan of 8 over 100. If we have a very quick look at the trig tables, it can give us an idea of the answer that we're expecting. And so if we move up here, our ratio is 8 over 100, 0.08. And just go forward and back so that and if you look over here, we've got 0.0875, and so 0.0699. The two ratios are between 0.7 and 0.07 and 0.0875. 0.08 is right in between those two, and what that indicates is that we're expecting the hill to have a gradient with a degree of around about between 4 and 5 degrees. So if we go back, we'll use the calculator to get something more exact. And so I'm finding an angle, so I'm using the arctan function of 8 divided by 100, and I'm going to go straight in, control enter in order to get the approximation, and we have 4.57 degrees, which is the degree measure of which is the angle that the heel makes with the ground. So that was 4.57 degrees. Okay, for example 3, we've been asked to find tan of A and measure of angle A given the following right triangle. And so what we do is we go to angle A. AB is our hypotenuse, 6 is the adjacent side, and BC is the opposite side. As you can see, the difficulty in this problem is that we do not have the length of BC, and so small application problem or extension problem, the first thing we'll need to do before we can complete the problem is to find the length of BC, and we're going to do that using Pythagoras' theorem. And so 12 squared will equal 6 squared plus BC squared. 144 is equal to 36 plus BC squared. BC is going to be 108, BC squared, and therefore BC will be the square root of 108. If you want that in simplified radical form, of course your calculator can take care of that for you. The square root of 108 in simplified form would be 6 root 3. And so in this case, I'll write that as 6 root 3, although using square root 108 is absolutely fine as well. 6 root 3 is the simplified radical form. Square root 108 is the exact value. Okay, now that we've established the value of BC, we can in fact answer the question, which asked us for the value of the tangent ratio for angle A, and the value of that is going to be 6 root 3, the opposite side over the adjacent side. And so in this particular case, we can simplify that, again not required, but you can simplify that as root 3. That should give you a small hint or indication as to what the measure of angle A is going to end up being, if you remember the lesson on special right triangles. If you don't, we'll go through it, but you should recognize that as one of the special right triangles, because the one of the legs is half as big as the hypotenuse, the other is √3, and that should indicate that we're going to get a measure, an angle measure of 30 degrees, I beg your pardon. And so angle A is going to be arctan of √3, and we can work that out on the calculator. Tan to the -1 of square root of 3, and that is of course 60 degrees. And so we have angle A equal to 60 degrees. Of course, it's a little harder to recognize if we had left it as square root of 108. That of course would not have affected the answer in any way, shape or form. If we had entered that into the calculator as arctan square root 108 over 6, it would have produced exactly the same answer. Okay, and so what you need to do now is turn your attention to the assignment, which is detailed on this note, or indeed maybe detailed on your planner, or whatever it is that your geometry teacher has assigned for you.